what we've done so far, let's just throw a problem up here on the board. That is taping? Yes, it is. Okay, so if I gave you something such as this, if I gave you y equals negative 4 cosecant of theta plus 3, okay? Now, you haven't done this since last Thursday, so you might have forgotten it a little bit, but I mean, you should be able to do this, okay? And if not, watch carefully. You don't need to write this down if you don't want to. I'll just make sure you know how to do it. First thing I do is I make little notes to myself here. First off, cosecant, I'm going to put underneath it sine. I'm going to do a sine graph first, and then I'm going to do a cosecant one after I get the sine graph done. And I put down vertically, it goes from negative 4 to 4. I'm going to make one more note to myself. This negative flips it. Again, you don't have to put that down, but you know, that way you're less likely to forget it. But it really doesn't go negative 4 to 4. I still have to add 3 to each of these. Plus 3, plus 3. So vertically, it really goes from negative 1 to positive 7. Okay? So, if we do that, we're going from negative 1 all the way up to positive 7. Halfway between negative 1 and positive 7 is 3. And then we have 2 pi, pi over 2. That looks terrible. And 3 pi over 2. Okay. And at this point, you really should be able to answer that a sine graph starts in the middle, okay? A cosine graph either starts at the high point or the low point. This is a sine graph, so it starts right here in the middle. Halfway through, we're right in the middle. All the way at the end, we're at the middle. And at pi over 2 on a sine graph, we're up here, but since we flipped it, we're going to be down here at the low point. And 3 pi over 2, we're going to be at the high point. So here's my sine graph. Now, if it was just a sine graph, if that's all it was just a sine graph, where would I put the asymptotes at? Nowhere. Okay, the only time you put asymptotes are if you're doing tangent or cotangent graphs, which we're not doing those. We're not doing those. I'm doing just sine, cosine, secant, and cosecant graphs. For sine and cosine, you don't have any asymptotes. Okay, but since I'm doing a cosecant or a secant graph, one of the two, you do need to do asymptotes. You need to do asymptotes. Normally, it's where it hits the x-axis, but since we moved it up 3 spots, it's where it hits 3. So I draw one right here, and right here, and right here. And then have the graph go away, because it's actually a cosecant graph. In order to do a cosecant graph, you do a sine graph first. Any question on that one? Nothing new there. That's what we were doing last week. Okay, just a little bit of review. Okay, so far, we've stretched them vertically, and we've slid them vertically up and down. Haven't done anything horizontally yet, okay? Horizontally, it's a little bit tougher. Okay, it's a little bit tougher. So, what we're going to do first today all we're going to do is stretch them horizontally. Stretch them or shrink them horizontally. Stretch or shrink, okay? Now, we could have, every one of these we stretched, okay? If you remember from back in Algebra 2, if I give you something like this, if I give you y equals x squared, well, if it was x squared plus 4, that moves it up 4. If I went like this, that moves the graph up 4. And you guys remember what the minus 3 does to the graph?
Right.
Moves it right 3. Remember what I said a bunch of times? It's been over a year since I said this. So all by itself, it moves it up and down what you think. In there with the x, it moves it left or right, the opposite of what you would think, as long as you're adding, subtracting, okay? Now, what if I multiply by something? Well, in this case, it's going to stretch it vertically by a factor of 10, okay? But if it was 1/2, it would shrink it vertically, okay? Because it's less than 1. Normally, it's just 1. There's a 1x squared right here. 1 doesn't do anything to it, okay? Bigger than 1 stretches it vertically. Smaller than 1 shrinks it vertically, okay? So, we're not dealing, but that's out front here by itself, does it vertically. Just like right here. Times by 4, it stretched it vertically, okay? Well, we're going to be stretching or shrinking it horizontally. So it's not going to be out here by itself, it's going to be with the x. But we're not going to add or subtract with the x, okay? We're stretching it. We're not sliding it, okay? Remember, when you add or subtract, it moves it. When you multiply, it stretches or shrinks it, okay? And we're stretching or shrinking horizontally today, so we're going to be multiplying. So, but what we need to remember is this. I'll say this real slowly. I've already said it once. Everything with the x is always the opposite. It's always the opposite of what you think, okay? And I didn't show you guys that back in Algebra 2. I'm going to show you right now, though. Sometimes students wonder, well, why is that? How come this one right here is the opposite, and this one, it does what you would think? Here's why. I said, with the x, it moves it left and right. X is left and right. opposite of what you think. I could rewrite this. Here's what I could do. I could minus 4 to each side. So the same equation as y minus 4 equals 1/2 x minus 3 squared. Okay? This minus 3 moves it right 3. This is with the y. It would do the opposite with the y. You would think it would move it down 4. It really moves it up 4. Just like we said over here. Okay? So what I'm getting at, I don't want to confuse people here, okay? You don't need to know what I just told you. You don't have to know it, okay? But in case you're curious, when it's with the x, it moves it left and right, opposite of what you think. When it's with the y, it moves it up and down the opposite of what you think. It's just normally y is all by itself, okay? So, anyhow, just throw that out to you. Hopefully I didn't confuse you too much. Okay, so let's do a basic one first. If I gave you y equals the sine of theta divided by 2, okay? So, we are not moving this one at all. We didn't add or subtract anything. We simply divided by 2. That's all we did. Okay, we divided by 2. And it's with the theta, or if it was algebra, it'd be with the x. So it's the opposite. I say with the theta, with the x, same thing. We should be using thetas, okay? Like I did. All right, so it's with the theta, which theta is the x-axis, okay? And we're going to either stretch it or shrink it. Think about it. You're dividing by 2. When you divide by 2, generally the numbers get smaller. So what do you think? Would you think it would stretch it or you think it would shrink it? You think it'd shrink it. Does just the opposite, okay? Does just the opposite. Everything with the x or everything with the theta is always the opposite. It's always the opposite. Okay, just like we did back in Algebra 2. Okay, so here's what you do. Vertically, it hasn't changed. All we're doing is stretching it by a factor of 2. Okay, vertically it still goes negative 1 to 1. What you do and what you want to do is you always want to write it, just to make it easier, you always want to write it as theta over something. Theta divided by something. Just trust me on this. You always want to have theta over something. And we'll talk about that in a minute if it isn't written like that. What you do, and we just said, you would think it would shrink it. It actually stretches it. Okay? It stretches it by a factor of 2. So what you do is you take this number 2, the number that you're dividing by, and you multiply what it normally goes to. It normally goes from 0 to 2 pi. Well, horizontally, everything's opposite, remember. What do you think we're going to do? We have 0 to 2 pi, but we're dividing by 2, so what are we going to do with those two things? The opposite. Okay, we're dividing by 2, so we're going to multiply by 2. Times 2, times 2. So horizontally, goes 0 times 2 is 2. 0 to 4 pi. It's going to go from 0 to 4 pi. So, here's 1, here's negative 1. We're not going to go 2 pi here.
4 pi.
We're going to 4 pi. Half of 4 pi is 2 pi. Half of 2 pi is 1 pi. Between 2 pi and 4 pi is 3 pi. Our sine graph starts, it's just a regular old sine graph. They just stretched it vertically or horizontally by a factor of 2. So we're still going to be at 0, 0, 2 pi 0, and 4 pi 0. At pi we're up here, 3 pi we're down here. And there's our graph. Now again, you might be going, oh, it looks like all the other ones. Okay. Except, normally it went from 0 to 2 pi. 0 to 2 pi. It was supposed to go from here to here. So we should have had 3 pi over 2, pi over 2. It was supposed to be here, 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 and here. So I'm going to do a dotted one. This is what a regular sine graph normally looks like. But they stretched it so it's twice as long. Instead of going from 0 to 2 pi, I want 0 to 4 pi. You don't need to do the dotted one also. I just want to show you that, again, all the graphs generally look the same, just because I don't draw them to scale, okay? I mean, if you want to, go ahead. I don't care, all right? But I don't draw them to scale.